Today we are working on something called completing the square. We have 4 sections left of the book. I love this time of the year because it really puts everything we've been doing all year together. We have a reason why we've been factoring all this time. So far, you learn how to factor. You learn how to solve quadratic equations by multiple methods. Now, so far, you've learned the square root method, right? Okay, we take the root of both sides, but this is limiting because it doesn't work if I have a linear term, like x squared plus 5x. Anything to the first power is a linear term. It won't work if I have a 5x, right? X squared plus 5x. Then we learned how to solve them by graphing. How do we figure out what x equals? By graphing and finding the roots. That was very long and involved, and sometimes when you're crossing and you're looking for your x-intercepts, or when you're looking for your solutions, it's between 2 boxes, so it's hard to estimate, right? So that's not something we want to use every time. The third method is the quadratic formula. Now, we haven't used that. We will show you that. That's basically a formula. You figure out your A, B, C, and you substitute into a formula. Okay? It's super easy. It's kind of the go-to method. It's why we don't teach it first, because then you'll only use that. And there are times where you're definitely going to want to do some of the other methods. The last one is the factoring method. This isn't the last one. Then there's the factoring. We learned how to do that, right? But not everything was factorable. Only about 10% of the equations that we even worked, of all equations probably, if you thought of things, will be factorable. That's actually, I wouldn't say 10%. It's not an accurate. But a small percent are factorable. Okay? That's only when they have integer roots, right? So then we have the last method, which is called completing the square. So if I look at all of these methods, we really only have completing the square left, and we've got the quadratic formula. So today we're working on completing the square, and both of which will work every time. Both methods work every time. Whereas square root doesn't work every time, graphing doesn't work every time, factoring doesn't work every time. Completing the square and quadratic formula work every time. And completing the square is guaranteed to be on your SATs. So it is definitely a teacher favorite. Last year, I remember my son's teacher, when he'd solve using the quadratic formula, he'd get no points. So he had to use completing the square. All right, so let's go. The idea of completing the square is that we create a perfect square trinomial. So in order to do that, we're going to have to get rid of that 7, because this is not a perfect square trinomial. So how would I get rid of the 7?
Oh.
Yep.
You would add 7 on both sides.
Perfect. Adding 7 on both sides. Okay. Now, I'm going to turn the left side into a perfect square trinomial. Okay, so now I'm going to try and create a perfect square trinomial. Who knows what number I would have to put in there to make it a perfect square, Nathan? A 9. A 9, right? So if I add 9 here, to keep the equation in balance, don't I have to add 9 here?
Yeah.
All right, now let's talk about how we got that 9. Yes?
You would divide b, or the middle term, by 2, and then square what you have.
Right. So in ax squared plus bx plus c, okay, we're taking that middle term, the coefficient of x, and dividing it by 2. And then we square it, right? Okay. So when I divide 6 by 2 and then square it, what does that equal to?
9.
And that's what I place here and here. You guys with me? What that allows me to do is factor this. What is this factor to? Ava? The root of that is x. The root of that is 3. So it's x plus 3 squared. Super easy to factor. And that equals what?
16.
16. You guys with me? Can I erase this bottom part? Okay, so I'm factoring. I added the 9 on both sides. And then we factored the left side. Now, what would I do to get rid of the square? I'm going to root both sides. Okay? And Django, when I take the square root of x plus 3, what does it equal to? Absolute value of x plus 3. Good. Equals 4. To lose the absolute value, what do I have to do, Django? Of what number? No. Of the opposite side, 4. So I'm going to say that x plus 3 is equal to plus or minus the 4. Now we do what? Subtract 3 from both sides. Negative 3 plus 4. You still need to write it out. Negative 3 plus 4, negative 3 minus 4.
So you've got either 1 or negative 7.
That is correct. And so my solutions are 1 or negative 7. Questions? 1 or negative 7. Okay, questions? Okay, so now, so that's it. What did you think? Yeah. Not that tedious. Okay, let's just do some exercises to get us ready for completing the square. Remember we said, what do I do to that middle term?
You divide by 2 in the square.
Right, we divide by 2. And then wait, what does that equal? 3. So isn't this x plus 3 squared?
Yes.
The root of this is x. We know that's a 3. It goes here. Okay, what would the next, and inside here, if I square it, it becomes a 9. Why don't you do the rest? Try the rest. Go. Pause the recording and do the rest. All right, let's check our work. So number 2, Charlie, what did you get for number 2?
M squared plus 12m plus 36.
Plus 12m plus 36. And what the outside, if I factored it, it's m plus 6. The quantity of m plus 6 squared. So what is this going to be? What is this? And you said it's plus 36. So what is this right away? What is it equal to? Yes. Y plus 9. And in the box?
8.
Right? Because I'm getting, what's the root of k squared? Minus 9, sorry. What's the root of k squared? K. And what's the root of, and then divide that by 2? Minus 7. And we square it, right? And it would be 49 inside. Now, again, let's try it. What's the root of that? 2t. Now, is it going to be a minus or a plus? A minus, because I've got that minus there. Now, I've got to multiply it by something.
100.
Hold on. Let's look at this. K squared minus 14k plus 49. We said the root of that is a k. We said the root of that is a 7. It's a minus and it's squared. Now notice how I get that middle term. Remember this? Multiply k times negative 7 and what do we get? Negative 7k. And double it? Negative 14k. Do you remember that? One more time, let's go with the formula. Let's Let's look at, it's a squared plus 2ab equal, this is just a general formula, plus b squared. And remember I said it's a, it's b, it's a plus sign. How do I get that middle term? Multiply them both together and double it. You guys with me? Okay, so we know that when I multiply this times 2 has to equal this. So what if I divide 22t by 2? What do I get? 10t, right? So 2t times what equals 10t? 5. So what goes in the box? 25.
Wait.
One more time, and I'm going to go fast because I've got a lot to do today. We know that you understand that when I multiply a times b times 2, I get the middle term, right?
Yeah.
On a perfect square trinomial. Well, we don't know. What's the root of this, Sid? Sydney? Sadie, sorry. 2t. Now, the thing is we know that it's a minus, right?
Yeah.
It's got to be a minus. But I don't know what goes here. And I don't know what goes here. But remember, we said we multiply here, 2 times AB, right? Well, what happens if I divide this by 2? Don't I just get this times this?
Yeah.
So divide this by 2. 10t. So 2t times what equals 10t? 5. That's where I'm getting the 5. Okay? And then we're squaring that, right? So if I square the first term, I get this. If I square the last term, what do we get? 25. That's what goes in the box. And when I multiply 2t times 5, and then I double it, don't we get 20t? Yes. Okay, am I clear here?
Yes.
Okay. We need to move on. I can't spend a whole class lesson on this. Sorry. You can review in the video, or you can ask at lunch. All right, so let's move on to our actual. That's just kind of getting used to thinking in the way of completing the square. But it's sidetracking to spend any more time than that. You know what I mean? All right, so what do we really have to do here when we're completing the square? Do you want to try this one on your own?
Yeah.
Okay, I'm going to pause it, and I'm going to come around. If you need help, raise your hand. Let's look at what we do. Step 1, to make space, what do I need to do now?
Okay. You need to subtract 5.
Good. Okay, next step, Django.
You need to add 16.
How did you get the 16?
So you divide 8 by 2, which is negative 2, and then, negative 4, then you square that, which
And we
is 16. And then you add it both sides, and then...
Okay, hold on. Plus 16, plus 16. Next step.
And then you're going to get 8x, or x squared, plus 4, since you take the square root of the... No.
Yeah.
X plus 4. And then
X plus?
X plus 4.
If I have a minus sign here, there's no
X
way.
minus 4.
Because what it really means is x minus 4 times x minus 4. There's no way to get it if you had x plus 4 times x plus 4. So it's got to be x what?
Minus 4.
Squared
Squared
equals
11.
11. Next step, how do I get rid of the quadratic?
You root that, you do both of them.
And we get,
x minus 4.
we do not get x minus 4, we get
Absolute value.
absolute value of x minus 4 equals what? Square root.
Square root of 11.
To lose the absolute value, what do I have to do? Yep. Okay, x minus 4 equals plus or minus square root 11. You should be writing the steps if your steps don't look like mine. Now, subtract 4, add 4. I get x equals 4 plus or minus square root of 11. Are you with me?
Yes.
And that is a perfectly good answer. I don't have to estimate. I can leave it under the radical. So this is, you can, but you're not going to because you're more likely to make a mistake unless they ask you to. And there will be times they ask you to. Okay? There will be times. So if that is two solutions. 4 plus, okay, square root of 11 is between the square root of 16 and the square root of 9. So it's about 3.3. So that's 4 plus or minus 3.3. 7.3 or 0.7. Do you see how I estimate it? But if they don't ask you to, don't do it. There will be plenty of estimating in the next couple weeks, but don't do it tonight because leaving it under the radical, unless it's asked for, it's more accurate. Yeah, quick, go.
Are you able to put where you divide by 2 and then square it later? Are you able to put that under your work?
Put it off to the side. Do not put it under the work. The same way I put it off to the side. Okay, so now, this one's a little bit more of a challenge. Why? Can you see what's wrong, what's different about this one?
Because you can't divide 5 from 2.
Right. Okay, so step 1, what am I doing? Go. Subtracting 6. And then I'm left with, what do I have to do to get that last term? What do I have to do to the middle term to get my last term? Yes.
Divide by 2, then square it.
Okay, so I'm taking negative 5. Notice it's off on the side, not in the middle of the work. And then we are dividing by 2 and then squaring it. Write it down. Square the numerator, square the denominator. Do not turn it into a decimal. Much easier to work in fractions. So what is negative 5 squared? And what is 2 squared? 4. So we are adding what? 25 over 4 to both sides of the equation. Now, on the right side, we have to have a common denominator. What am I multiplying that 6 by? 4 over 4, not 4. Right? So we get negative 24 over, over 4. You with me? Plus 25 over 4. I'm just going to keep simplifying that side. What does that simplify to? 1 over 4. You guys with me? Now on the other side, what do I have to do to that? We just factor it. What's the root of x squared? X. Is it a minus or a plus?
Minus.
Okay, what's the root of 25?
5.
What's the root of 4?
2.
Isn't that easy? Okay, now what? Okay, one more time. You got confused on the factoring of that part?
Why is there a fraction? How is the fraction equal?
Well, what's the root of that?
X.
Okay, what's the root of 25?
5.
What's the root of 4?
2.
Good. You understand how I got that?
Yeah.
Okay, and hold on. So I've got that. Do you understand how I got that so far?
Yeah.
Okay. What you're doing, Sadie, I wanted to call you Sydney again. Okay. Sorry. What you're doing is you're going to the end in your mind, and you're like, oh my God, I can't do this. Stop. Take it a step at a time. So now what's the next step?
I'll root both sides.
Root both sides. Okay? Now, the left side becomes
X minus 5 over 2.
absolute value of x minus 5 over 2. And the square root of 1 and the square root of 4. 1 over 2. Okay, I would just probably go right to that. So, x minus 5 over 2, to lose the absolute value, it's going to make it plus or minus 1/2, right? Now, I have to add 5 over 2 to both sides. You with me? And then I get 5 over 2 plus 1 over 2 and 5 over 2 minus 1 over 2. So 5 halves plus 1 half makes 6 halves. What does that equal to? 3. And 5 halves minus 1 half makes 4 halves. Okay, questions? Okay, are there any questions? Okay, so that's how we deal with non-perfect squares. Okay, ready? Can I keep going? Okay. I'm going to skip this because I have to show you lead coefficients. Okay? My clock is slow. Okay. So let's go to a lead coefficient. Okay. Step 1, make your space. What do I do? Right as we're going, we add 4. Okay? Now, get rid of the lead coefficient. So divide all terms by 2. Now this doesn't matter if you divide by 2 first and then make space, or make space and then divide by 2. So 2x squared divided by 2 is x squared. 7x divided by 2 is still 7x over 2. 7 over 2x. And the other one. Now, what do I do with the middle term every time? So when I have 7 over 2 and I divide by 2, or divide by 2, doesn't it equal? This means the same thing as this. 7 over 2 divided by 2, right? Do we divide fractions? No, we multiply by the reciprocal. So when you have a fraction and you're dividing by 2, you're really going to be multiplying by a half. So what does it become? 7 over 4 squared, which is? So I'm adding 49 over 16 to both sides. Okay. Now, what am I doing? Okay. Now I'm going to factor. I'm going to factor. What's the first side? What does it factor to? X plus
7
over 4 squared. And this I've got to change the 2, multiply it by 16 over 16, right? So it becomes 32 over 16 plus 49 over 16. Are you guys with me? Okay, 32 and 49 make what? 81. Okay, now what? We root both sides, and this is the most beautiful numbers you've ever seen because we love 81. This is what we call a pretty number because what's the square root of 81?
9.
And the square root of 16?
4.
Okay, absolute value equals 9 over 4. To lose the absolute value, it's plus or minus. You need to stay until I finish a couple things. I'm almost done. 7/4 plus 9/4, 7/4 minus 9/4. It's 2/4 and 16/4, negative 16/4. So it's 1/2 and negative 4. One more thing I have to show you. Are you guys good?
Yeah.
You understanding this point? Okay? Now, this was beautiful. It's all good. We love 81. We love 16. But what happens when we get something that's not so pretty? Okay? Now I'm here. Right? 13's not a perfect square. Whatever happens, you must always rationalize the denominator. If that happens to be a radical 5, you're going to have to multiply by rad 5 over rad 5. Okay?
Attention, students. The library is closed today.
So,
During lunch, the library is closed.
Shh. So, I'm adding 5, 6. Now look. What'd you say? So I'm adding 5, 6 plus rad 13 over 6. Can't I just say 5 plus or minus rad 13 all over 6? And that's your final answer. Do you understand what to do with the not so perfect? Okay, that's the end.